This is geometry lesson 13.2. We're going to be looking at the angle bisector theorem. So the bisector of any angle of a triangle splits the opposite side into two segments whose lengths are in the same ratio as the sides, including the original angle. A lot of words there, but this actually makes a lot of sense. This one's real easy to use. So in lesson 6.2, you learned that the bisector of the vertex angle of an isosceles triangle, so looking at the picture on the left, we've already learned this. If you have an isosceles triangle, which remember means you have two equal sides, all right, and the vertex angle is the angle between the two equal sides. If we draw a line that bisects that angle, cuts it into two equal pieces, okay, the opposite side there is also cut in half. So that's what we learned about an isosceles triangle. It's a symmetry line for the triangle, so that's what we get to in here, meaning it's going to be the same on both sides. So I have two equal sides that make it isosceles. I draw this line, these angles are equal here, and it cuts the base into two equal pieces as well. So it's a line of symmetry, both sides are equal. So this means that the angle bisector also divides the opposite side right here into congruent parts. So the natural question that might follow is, well, what if the triangle is an isosceles? If I draw an angle bisector, so I'm not just drawing a random line anywhere I want, it's going from this angle to the opposite side, but it's cutting this angle into two equal pieces. Okay, what's the relationship then between P and Q? Because obviously now they're not equal to each other like it is in an isosceles triangle. That's a very specific, special case. But there is actually a relationship here between P and Q and A and B. So if we look at the angle bisector theorem, the bisector of any angle of a triangle divides the opposite side into segments whose lengths are proportional, continuing with what we've been looking at, to the adjacent sides of the triangle. So the adjacent means next to. So the angle that's being bisected, the adjacent sides are A and B. Remember that means next to. All right, and then these are the segments on the opposite side that they're going to be proportional to these adjacent ones. So that means I can set them up in a proportion. So A over P is going to equal B over Q. So the relationship between those two, the comparison of their size, is going to be equal. So P and Q are not equal like in an isosceles, but the relationship between these sides is going to be equal. You can set this up this way. We talked about in the last chapter how we can set up these proportions differently. I could say A over B equals P over Q. That would also be correct. A compares to B the same way P compares to Q. And notice when I cross multiply here, it's A times Q. Over here, it's A times Q. It's P times B. It's P times B. So I haven't changed the cross multiplication. Therefore, this is going to give me the same result. So this is nice and easy to use here. Let's run down to example number 1. Suppose that BD, this line segment, bisects angle ABC. So if it's bisected, that means that these angles are equal to each other. They want you to find X. So based on this angle bisector theorem, I can set up two equal ratios called a proportion and then cross multiply to find my missing piece. So there's two different ways, actually there's more than two, but the two most obvious ways to set this up would be to just stack it the way you see it. So X over 10, that relationship is going to be the same as 24 over 16. Or just like I showed you up here, you could stack up the adjacent sides over the opposite sides. So I could do X over 24, this to this equals this to this. And notice it's still 24 times 10, it's still 16 times x. So either way is going to work just fine, doesn't really matter. So cross multiplying here, it's 16x. Cross multiplying here, 240. Quick divide by 16, and x comes out to 15. So this side is 15. So 15 compares to 10, the same way 24 compares to 16. That should make sense. If I went ahead and divided those, 15 divided by 10, 1.5, 24 divided by 16, 1.5. Okay, they're in the same relationship. If I go ahead and just write them as a simplified fraction, 15 over 10 is 3 over 2. 24 over 16 is also 3 over 2. So they're in the same relationship. That's what this theorem states. If the angle is bisected by a line, it's going to cut the opposite side of the triangle into pieces that are proportional with the two adjacent sides. And that's all we're looking at today. A couple different situations that involve that, but that's the basics. So as we flip to the back, we've got example number 1 over here. Additional example number 1. It's going to look just like the one we just did. So this, they have to tell you, is an angle bisector. If it's just a random line, it's not necessarily proportional here. So this has been given as an angle bisector. So therefore, these are going to be in proportion. A couple ways to set it up. You could do the matching adjacent side with the opposite side. So you could do 30 over x compares the same way. 45 compares to 15. Notice I didn't just go around in a circle. You need to be consistent, left to right, left to right. Or you could have stacked it kind of the way you see it, 30 over 45. So 30 compares to 45 the same way x compares to 15. And notice again, 30 times 15, 30 times 15, 45 times x, 45 times x. So both of these proportionals are equivalent, it's the same thing. So when I cross multiply, I get 45x. 30 times 15 is 450. Divide by 45 on both sides, and x equals 10. All right, so pretty straightforward there. So let's look at two examples that are not quite as straightforward. Not all of the information is quite given in the same way. Example number 2, first of all, they tell you that LN is bisecting KLM. This is the angle being bisected. Okay, it's equal on both sides, which means the opposite two pieces right here, these segments will be proportional with the 8 and the 10. All they tell you is that KM, the entire side over here, is 15. Find KN, so we're going to call that X. All right, how are we going to set this up? Well, first of all, this side, we could just set it up like we see it. X over 8 equals this over 10. So the trick to this question is, what are we going to call this? So we called this X. What are we going to call this? We can't just call it Y or something else, because then we're not going to be able to get an answer here. So we have to use the 15 to figure it out. Whenever you're stuck with a variable and you don't know how to write the expression for something, think about what you would do if this was a number. If this was 10 and the whole thing's 15, you would tell me this is 5. You would do 15 minus 10 to figure this out. If I told you this was 2, you would do 15 minus 2 and tell me this is 13. So to figure this piece out, what I'm doing is 15 minus x to get this. That's what this is equal to. The whole thing, take away x, leaves me this answer. So we're going to call this 15 minus x. Whatever this is, take it away from 15. That's the length here. So it's 15 minus x. Now I'm just going to go ahead and cross multiply that. This times this, that's going to give you 10x. This times this is going to be 8 distributed to 15 minus x. Go ahead and leave that side alone for a second. Let's distribute. 8 times 15 is 120. 8 times minus x is a minus 8x. To get rid of that, I'm going to add 8x because it's negative. All right, so I get 18x equals 120 divided by 18. Now, if I go ahead and try that, 120 divided by 18, that's 6 2/3. We do need to recognize that 0.6 repeated is 2/3, but I'm not going to write this as 6 2/3. We really don't use mixed numbers at this point. We just use improper fractions. And I'm not going to write 6.6 repeated because, again, that's not a very useful number. So if you don't get a nice decimal, we want to go ahead and leave this as a fraction. So I'm going to do 120 over 18, and I'm going to simplify it. It's 20 over 3, which again is the same as 6 2/3. 3 goes into 26 times with 2 left over, 6 2/3. But 6 2/3 is not a useful number to us. 20 over 3, much more useful. Okay, so this is 20 over 3. And then if they wanted you to find this one, you would actually do 15 minus 20 over 3 to find that. They don't ask you to do that, but just in case, there could be a future question. Then this would be 25 over 3 over here. So you'd have 20 over 3 and 25 over 3. And if you added those together, of course, 25 over 3 plus 20 over 3, what should we get? Well, we should get 15 if we've done our math correct. And there you go. All right, last one. Same idea. If you're watching this on video, I would ask you to pause the video and try it. It's going to look just like example 2 above it here. See if you get it right. All right, hopefully you've already tried this one. The information that they've given to us here is that AC is 28. This, of course, is an angle bisector over here. If it's not, none of this matters. Okay, we can't do any of this unless this is an angle bisector. They want you to find CD, so that's what we're going to go ahead and call X. So I can line that up with the 45. This piece is going to line up with 60. So X over 45 equals whatever I'm going to call this over 60. This over this equals this over this. So just like we talked about before, if I knew what this was, if this was 8, I would do 28 minus 8 and call this 20. 20 and 8 would be 28. So I'm subtracting whatever X is from 28. So I'm going to call this 28 minus X. All right, now I'm going to cross multiply. X times 60 is 60X. On the other side, 45 is going to get distributed to all of this. Make sure it goes to both. So 45 times 28, I've got that number here, is 1260 minus 45X. A minus 45X means you're going to add it. All those algebra skills coming back. All right, and it's a 105X equals 1260. We're going to divide by 105. And X equals 12. Okay, so that piece right there is 12. CD is 12. And of course, now if this whole thing's 28 and this is 12, you would just go ahead and take that off. This must be 16. So if you needed it, it would look like that. You could check your answers here. Compare 12 over 45. That ratio needs to equal this one. So 16 over 60. Boom. They're both equal. They are proportional. I know I've got this done correctly.